this man right, or is he not? Does ethanol save oil, and does it reduces pollution? Actually, we don't know. You may have an opinion on it. I guess most of you would say yes, of course, bioethanol saves oils and reduces pollution because it's made from natural resources, so it should be better for the environment. The problem is that it is an opinion and not the result from a calculation. And if you want to have an objective point of view, you need to do some calculation. Because if I change the picture, if I show you the whole picture, what is behind ethanol, so what you get at the gas station, there's a whole process behind the bioethanol. You have to take some land to cultivate some corn, for example. So if you want to cultivate some corn, you need some chemical fertilizer. You need some machines to spread the fertilizer. That could be trucks, that could be planes. You also need to spread some pesticides. And then once you have your crop, you need to process it. So you need to dry it, and then you need to produce ethanol from your cornstarch. And finally, you have to store it, to distribute it, and and you also have the gas station device. So you have a lot of steps, of phases, I would say, behind your ethanol. And at each step, you will take some materials from the nature, and you will reject some waste into the nature. And the idea of life cycle is to evaluate this. So when you see such a cartoon, you can, what we can say is that we need to change our habits. We know that. We know that we have to change, but we need to know how to change them. And we need a tool to do it in the right way, and this tool is life cycle assessment. So the LCA principle is represented on the scheme. So basically, you have the Earth, the environmental compartment, and you have what we call the technosphere. And the technosphere is, for example, for your ethanol, it will represent all the different steps from the raw material extraction, the manufacturing production, the transportation, the use phase, and the disposal and the recycling. So this is the life cycle of the ethanol, or ethanol or your product, whatever you want. And at each step, LCA will assess the materials and energy flows taken from the nature or released into the nature. So we do this assessment at each steps, and then we convert those flows into impact on the environment. I hope it's okay for everyone. So with such a method, which is objective and it's a scientific calculation, with such a method, you forget your opinions and you learn how to calculate what is good for the environment or not. So if I have a few words to say about the LCA methodology, so it's a methodology to assess how products, processes, or services impact the environment. LCA is internationally recognized by institutions of such as the UNEP, United Nations Environment Program, the SETAC, Society of Environment and Toxicology and Chemistry in the United States of America, And it's also recognized and really widespread in big companies. For example, in France, we have Total, EDF, Veolia, well, a lot of companies use life cycle assessments. LCA, so I will say LCA for life cycle assessment in the following. LCA is it's a methodology that is defined by the ISO standard and the 1440 theories. And it's the number one approach for assessing impact on the environment. It's a powerful tool for decision making, strategy, and lobbying. And it's used by companies, but it's also used in the research field. I use it in my research field. And it's also used by the administration, such as the Ministry of Environment in France. Okay. So in this course, what are the main outcomes? At the end of the module, you will know, of course, the principle of LCA, its vocabulary and main steps. You will be used to the life cycle thinking. You will master the methods of producing an inventory, a life cycle inventory. You will be able to tackle a multifunctional process. And after, so this is the first step of the LCA, and then you have to analyze your results. So you will be able to do this, to evaluate the impact, compare scenarios, assess the methodological choices and limits. And eventually you will be able to evaluate and produce a full life cycle assessment up to the industry standard. So during the course, you will have 7 face-to-face sessions of 3 hours. So in each session, you have a lecture. So I do the lecture. It's between 1 hour and 1 hour and 30 minutes. And after you have, most of the time, you will have a tutorial class, in which you solve exercises and case studies under my supervision. So 5 sessions will be with tutorial classes. 1 session will be with a presentation made by the students, so I mean by you. So you will have to study an actual LCA report, and you will have to present it to the class. And the last session will be followed by a final exam. You will also have 1 consolidation session in autonomy, in which you will have time to study your case, your LCA report, I mean, and to prepare your presentation. So 8 sessions in total, 7 face-to-face sessions, and 1 consolidation session in autonomy. So this is the example of the kind of report you could study. So here is a report on the comparison of drinking water systems, so bottled water, tap water, and home delivery water. So in this report, you compare those scenarios from an environmental point of view. Okay, so the outline, so that's the detail of the course. I'm not sure it's very interesting for an introduction, but actually I can then tell you a little bit more. So there will you will have an introduction on the life cycle thinking, the standards for LCA, and then we will detail the 4 main steps of the LCA, which are goal and scope definition, function and functional units, and defining the different types of flows, not fluxes, flows, sorry. You will learn how to conduct a life cycle inventory for a mono or a multifunctional processes. So multifunctional processes, for example, CHP, combined heat and power generation. You have the same process produces two products which are heat and energy. So that's a multifunctional process. We will learn how to handle recycling and how to perform a matrix approach, because there are some mathematical technique to solve LCA problem. We can solve it by hand or with metrics. So you will learn both of them. I give you a word about consequential LCA. We will talk about the main impacts on the environment and how to assess them. And of course, we will perform some result interpretation and critical assessment. How you will be assessed during this course. There are three parts of your evaluation. There will be a quiz at the final session. So it will be approximately 20% for the quiz. After the quiz, you will have a problem. It will be 50% for the problem. And I told you, you have to make a presentation in front of the class, and 30% of your final mark will be for this presentation. Okay, so I guess I'm done. If you have some question, I'll be glad to answer.
Excuse me, Professor.
Yes, I can hear you. I can hear you.
What's the difference between this final exam quiz and final exam problem solved?
Can you speak in your microphone? Because it comes and it goes out. Say your question again, please. Hello? I could not hear the question. Could you repeat it?
Okay, is my voice clear?
Yeah, it's better.
Okay, the question is, what's the difference between the final quiz and final exam?
The final what and the final what? I don't understand.
The
I
final
will
quiz
write
and
it.
the final exam.
The quiz is just some you have like I don't know 20 questions on the course, and after this, so it will last like a quarter to 20 minutes. So you just have to enter the questions. It's really simple, and then you have one exercise to solve. So the exercise may last like 2 hours, and the quiz like 20 minutes. Is it okay? Okay. Other questions? Okay. Well, if there's no other questions, maybe my colleague Vincent Chevrier may take the following. I don't know if he's here. Thank you. Okay, so I will leave the conversation. If you, yes, Sakib, you have a question? No, you say goodbye. Okay, so goodbye. Maybe I will see you soon. I hope. And if you have some question, you may join me by email. Samira will give you my email. And what I did not show you is the schedule. Well, the schedule is between the end of May and mid June. Okay, I get the first session is the 26th of May, and the last one is the 17th of June. That's it. Okay, bye bye everyone.
Bye bye. Thank you.
Thank you.
Thank you very much.
Thank you.
Hello, everyone. Maybe we can start the presentation of the elective unit.
Yes.
Did you agree? Yeah?
Yes.
Yes?
Thank
Okay, so this one is better. Okay, so I'm Vincent Chevrier. I'm a professor of computer science, and I will present you a teaching unit called Co-Simulation of Processes. And this teaching unit will be made jointly with Denis. So I have to share my screen. Let's say this one. And okay, I think it's okay for. Do you see my slides? Okay, thanks. So I will speak about something called co-simulation of processes, and this is a teaching unit made jointly by someone in computer science and someone in electrical engineering. So to start the presentation, doesn't work. Oh, okay. So let me introduce a simple question: can my house be autonomous in energy? That is a question that we can ask about having some PV panel or windmill, etc. So to answer that question, it will depend on the local weather, the thermal behavior of the house or of the system in question, about the thermal regulation you put inside the house, and also the behavior of inhabitants and how they consume energy, if they are present or not at home. Also, it can depend of local renewable energy sources, that can depend of weather. It can depend also about energy storage, for example, battery or hydrogen, etc., etc. And to answer that question, a simulation approach can be a choice tool because it helps in the design and assessment of alternative. And if we focus on the different domains involved with such a question, so I said we have the weather. So we, for example, we need the weather data to make simulation, and the behavior of the house and the thermal behavior will be not the same if you are at Barcelona or in, for example, Nancy. It will depend also of the thermal model of the house. You need some model of the human behavior, because you need to represent people at home or not and what they are their activities inside the house. To regulate the house, you need some thermal controller. Also, if you have some renewable energy, so maybe you can have windmill or PV panels. And if you have local energy sources, you need to manage the power, maybe also to ask the grid for extra power, and also to manage the storage of energy for battery or hydrogen. And this picture makes appear different domains of expertise. For example, the domain of expertise for production of power from a windmill is not the same as the domain of expertise for thermal behavior, and it's not the same as modeling the human behavior. So you have different domains, you have different models inside the different domains, and you have also links between all of that models because they are interacting. Because the human behavior will have an influence on the way the house is regulated in a thermal perspective, and also the weather will have an influence on the house heating or not, and also influence about PV panel, etc., etc. So you have different models, different links, different interactions. So it's a complex system. And facing this kind of problem is a problem of heterogeneity integration, because you have different models, maybe coming from different tools, maybe different formalism. And one solution is, okay, I will put all the models inside one software. For example, MATLAB, if you know MATLAB, or PowerSim, or etc. You choose one, and it's your favorite modeling and simulation tool, and it will work. It is fast to develop the system because you know your software, so you are very efficient in developing models, so it's convenient for you, but it's ad hoc. That is, it's only made for this application. But are you expert on all the domains? For example, if you have some skills in, I don't know, for example, energy systems and power energy system, are you expert also in modeling people behavior? Or are you expert in, I don't know, storage system, for example? And maybe you can have also intellectual property concerns. That is, the models you need are belonging to a society, a company. And the company can provide you some part of the model, but not the model itself. So it can be difficult to have that. And what about reuse or extension? For example, if you need to model communication networks, I guess you are not very skilled to develop models of computer communication. So maybe it's better to use some models. Okay, so what about reuse if you are developing with your models? And if you need to extend your system, for example, instead of modeling one house, you have to model the 10 hours, for example. So how do you scale up your system? Is it easy, etc.? The second solution is co-simulation. That is, you have different tools and you make them interact to build a simulation. And this is called co-simulation. So advantages for that is you can reuse different kind of models. You have, for example, in Modelica, you have a lot of libraries of models. For example, if you want models of house, you have model of house, thermal behavior of house. If you want model for a PV panel, you have model of PV panel, etc., etc. So you can reuse existing model. You can deal with intellectual property and industrial standards too. For example, we will teach you with FMI and Modelica. And also it can be interesting because the approach can be modular. You start small and incrementally you add different things. If you want to remove one model by another one, you can also do that, etc., etc. And also you can have different hybridation of management on that. The problems are you need to integrate software because simulation tools are software, and you need to integrate them. And also you need because each subsystem will behave not independently, but have to be synchronized with others. So you need to manage the simulator synchronization. So this is the goal of this teaching unit. How can we integrate externalities to provide you a global picture of what is co-simulation, why this approach is necessary for modeling and simulation of energy system, and it will provide you with knowledge and skill for designing, implementing such system by co-simulation. And at the end, you will be able to demonstrate knowledge about the fundamental concept about co-simulation. Also, you will be able to deal with the challenge and solution for co-simulation, and you'll be able to practically reuse some co-simulation tools and implement energy system as a multimodal. So to do that, we will start by providing just general knowledge about the theory of modeling and simulation, about concepts, about modeling and simulation, about co-simulation and multi-modeling. Then you will have a block about a tool called Modelica. Modelica is a standard for describing equation system, not all, but equation system. And Open Modelica is an open tool for doing that. And FMI is standard. So, and with something called FMU. So we will have some technical element from that. And then, since you know the technical part, we will follow with the principle of co-simulation with something called FMI and how to handle FMUs with Python. And then you will have to use all that knowledge to solve the question of energy autonomous house. And then a defense, feedback discussion about what we'll learn and things to improve. Just before having the question part, what is important here for the labs, okay, this question about application here, the focus is not on the problem to solve. Yes, it's on the co-simulation perspective. Okay, we need to reuse, extend, and do with that. So to do that, we will focus on something called agile approach. That is, start with a small step, achieve it, assess it, and then improve it. And we are not focusing on equation or models inside. So this is more on about the approach of co-simulation, the way you have to think about integration of heterogeneous component, how to develop things, some maybe developing simple, very simple dummy models, but just to try the global logic and then improve one model by replacing a simple one with a more complex one. Okay, so just to have in mind, the application part will focus on co-simulation perspective, the way to put different subsystems together to build a co-simulation, and not the way to write the equation of the PV panel according to the dust on the PV panel, the wind because I don't know what, and the external temperature, etc., etc. Just something. About assessment, it is a written report and oral presentation with a mean about the 2 marks. That's the end of my presentation. So if you have question or interrogation, I will be glad to answer you. Some question? Not? Everything is clear? Everyone is resting? Maybe it's the time after the lunch.
Yes, we
Yes.
are here. We are discussing about the.
Yes.
That looks interesting. Yeah.
Thank you.
Thanks. Maybe something to add because you will have to deal with Python, and it's not the problem. Python is not the problem. You need to know a little syntax about Python, some notation, but I'm also teacher of Python. So if Python is not really a problem, if you are not familiar with Python, first you will have some courses about Python, and second, I can provide you with extra information. No question?
I have another question.
Yeah.
The final submission, is it individual or is it in the group of 4 we will be working on?
Oh, yes. Very good question. At the beginning of the teaching unit with Denis, we preferred to have some individual reports, and most of the time, groups of students prefer to provide a global report for the 4 people in the group, for 3 or 4 people in the group, because they share their knowledge, they work together, and it's difficult to have separate things. So I think this year it will be a global, a common report with different people. But during the defense, some question can be about the individual contribution to the global picture of the project.
Okay, thank you.
Another question? If there is no more question, I will disconnect. If you have additional question later, you can join me by email. So my email, I think you have it, either in with Teams or in Vincent.Chevrier. This is first time dot name at univ less univ.loren sorry univ.loren.fr. Okay, that's equal. Or Vincent Chevrier, Vincent.Chevrier@loria.fr. You can ask me additional question if you want. And if there's no more question, I will leave the application. I wait 10 more seconds and then I disconnect.
Thank you.
Sorry? Is there a question?
No, thank you very much.
Oh, okay, thanks.
No, it was
Okay.
not a question. It was just thanks.
Okay, yes, sorry, because I didn't understand. Okay, goodbye. See you later,
Goodbye.
maybe. Goodbye.
Thank you.
Bye. Thank
Bye.
you.
Thank you.
Thank you.
Thank you. Bye.